So on the topic of AI, it is now time for our AI panel discussion. So would you please welcome to the stage Vivek Juneja, Head of Engineering for Cement and Alcemy, Noah Miller, COO at Carbon Re, and Scott Ziegler, CEO of CemAI. Thank you. Right, thank you guys. We're going to probably overlap a little bit with some of the things Berkan was just talking about as well, but I think getting your perspective as well as the producers is a really interesting way to approach these things. But before we do get into some of those more detailed questions and some of the complicated aspects around it, let's kick things off with a bit of an introduction. So starting at that end, Noah, tell us a bit about who you are and what Carbon Re do in the AI in cement world.
Good afternoon, everybody. Thanks for sticking with us as we get closer to network drinks at the end of the day. I'm Dr. Noah Miller, COO at Carbon Re. We're building fully autonomous AI control systems for the pyro process, and that's backed up with half a decade of experience controlling the pyro process in our customers across the world, reducing cost and carbon. My role as COO is really implementation, making our control systems work in the control rooms across our customers. But before that, I was also head of machine learning, so I've been involved in building the whole stack of the control and modeling systems that we implement today.
Okay, thank you. And Vivek, same question to you.
Yeah, I work at alcemy. I lead the cement engineering at alcemy. I represent the team here today. Alcemy, if you have already heard about it in the last presentation by Mr. Bodan, who we really work closely at the Simper OA group. We work from cement to concrete and help optimize the strength and reduce the clinker factor over time. And I think that is the biggest contribution that we are doing for our cement producers to reduce CO2 emissions. Our main role is turning reactive optimization to proactive optimization through machine learning. And I think we're just getting started. So I and my team have been working at different stages of our cement product line. So working from ingesting large amount of data that our cement producers generate, making sure they are trained with our machine learning algorithms, and then they get really high quality and performant predictions from our side.
Okay, thank you. And Scott, same question for you.
Yeah, thanks, David. So CemAI offers really off-the-shelf solutions for process optimization across the entire plant and predictive maintenance from the quarry to the loadout. We are and have been from the beginning cement-focused. We are born, bred, raised through the cement industry. The developments have all been done with the cement industry as well. Myself, I've been in the industry for 20 years, and all of our employees as well share in our background on the cement side of things.
Okay, excellent, thank you. Well, going back down to that end of the row, starting with you, Noah, I mean, Berkan mentioned or sort of described AI and digitalization as almost like an unsung hero in the decarbonisation process. How fair do you think that is to say, and what would your estimate, I guess, would be of the impact that decarbonisation can play in enabling the decarbonisation of the cement industry?
Absolutely, I think it's critical. And maybe the nuance is, I think people underestimate the process challenge that decarbonisation is, all the things that we need to do to decarbonise, whether that's alternative fuels, whether that's different raw materials, whether that's clinker factor reduction. Those are all process control problems that increase a huge amount of instability. And so where AI comes in is by reducing that instability and allowing those strategic objectives to be hit through those processes.
Vivek, I saw you nodding along. Do you have the same thoughts?
I mean, we as humans overestimate in short term and underestimate in long term.
Right.
And I think the same thing applies for the greenhouse effects, reducing that over time. I think to Noah's point, one of the things to look out for is some of the initiatives need to be started having a long-term goal, but having clear short-term milestones. So a lot of the opportunities where cement producers have is to have a clear ROI that often our customers have gotten under for 5 months. But keeping the long-term goal consistent, because a lot of it, as you heard Mr. Burden saying, is culture transformation, making sure that people are comfortable with that change, and that takes a really long time. But definitely we have seen from our customer conversations and observation that this is slowly affecting reducing the emissions on carbon dioxide.
Yeah, I think, I'll put it succinctly. I think that AI is the lowest hanging fruit out there right now for decarbonization. From cost to time of implementation to ease of implementation, it is by far I'll call it the easiest one to take the first step in. It is not capital intensive, and again, I think it has been demonstrated enough across different parts of the process to really show the value very quickly.
Okay, and in that case then, speaking of low-hanging fruit, and like, what has been one of the main barriers holding producers back from adopting it and reaching for this low-hanging fruit?
Yeah, I'll start because I'll take some of the things that Birkin mentioned, which is the tremendous amount of data that is available right now. It seems to be a concern that, am I prepared? Am I ready? Do I have enough information? Do I have enough data? The short answer to that, and this is not a selling point, but the short answer is there is enough data. There always is enough data to start, even if it is something small. That seems to be a big pushback. We do compete against some of the capital, some of the spending when it comes to whether it's process optimization or maintenance or any of the other items that you look at as far as AI goes at the cement plants. We're competing for that same funds. To Vivek's point, though, the return on investment is so quick, and it is such a fast turnaround. I think it's almost doing yourself a disservice not to get started.
Absolutely. Yeah. I think I could add to Scott's point. I think the infrastructure required to make sure the data is clean and the data health is quite high. Used to be very high, maybe a few years ago. I think with all the advances we are seeing on language models, agentic AI, we have seen some great improvements where machines can help and augment the improvement of the quality of data. So the barrier is only getting smaller and smaller over time. I would say one other thing, the barrier that comes from our experience has been the mindset change. Building confidence in these algorithms, especially when you're building closed-loop systems. As humans, we take a lot of pride in our expertise, and that's never going to go away. But I think the closed-loop systems and our implementation has shown that the systems are getting smarter and really powerful on a day-by-day basis. So having the kind of the mindset that the shift is happening pretty quickly and being able to build capabilities over that, as humans will become more of a decision makers and augment those capabilities over time. I think that is what I will say is another barrier for adoption.
Okay, and sort of following on that human point, have you found, ever faced any sort of skepticism potentially from plant teams that might be worried about things like job security or the results that the software and the process is going to produce? And if so, how do you overcome that? Oh.
I think that was what I was going to talk about for the last question, so that's helpful. I think what Vivek was saying, that trust aspect is really key in two ways. We saw there was the first question on the last panel was, where should humans be involved? Mm-hmm. That's always part, and right down to the operators, they want to understand exactly what the system is doing and why, so they trust it to run for longer. And what we found is that explainability is so important. If we can show them why is the control system making the decisions it's making, they can feed back on that. We can build that trust very quickly and go from they want to turn it off if it's difficult to they want to keep it on if it's difficult. But I think the other aspect of trust comes, unfortunately, from a lack of trust in AI providers. And lots of people at this point have had a failed project, have been burned by someone who didn't understand cement, who didn't really know what they were getting into with industrial data, who came into their plant promising the world and didn't have any results and experience to back it up. So I think the other side of that, there's trust for the operators, how's the system working, and then there's trust for either management in plant or management across the group of, are you working with someone who has proven results in cement, who deeply understands your cement, understands cement as a process and your nuances? and that can build the trust in both sides.
I don't think it's as much a concern of displacing folks either. We saw earlier, and we started to use this human in the loop kind of concept as well. You know, you're not always displacing someone. That's never the end game. That's never the thought process here. When it comes to everything from model fine-tuning, new equipment, new sensors, updates to the process, on top of that, as our colleague from Sempor was mentioning, this is attracting new talent. This is new talent that's not been in our industry before either. And that's a very, very positive thing. When we think about the retirements, we think about the aging out of a lot of the workforce, it's still such a good opportunity to take that next step, to use a lot of that knowledge that's already there as well. You know, so if you're building on a process optimization, the opportunity to run it in open loop and use more information and let your control room operators make the decisions. On the maintenance side of things, you're still going to have to replace equipment. You're still going to have to do the basic maintenance that's there. So this is less of a reduction of human, but keeping more of the human in the loop and more engaged from my perspective.
Okay. I want to quickly support that. I think I want to quote one of the comments we heard from our customer, Cecil, where they talked about having a lot of these tools in their plant team's hand, almost having them superpowers. And the role of the plant teams is augmenting a lot of the capabilities we are building by extending it to the, for example, the unsolved problems around that. So when the problem of strength predictions is being solved through closed loop, the staff is retrained and upskilled to tackle the other hard parts of it. So again, we will start seeing a bit of shift in the type of work rather than complete displacement. And I would also second what Noah mentioned. A lot of the trust comes through transparency. So again, at Alcemy, we sometimes take a lot of time to explain how the machine learning really is working behind the scene to build that confidence. And we have seen explainability and transparency really helps to build that trust for a lot of the people in the teams.
Yeah. Okay. Maybe just... Yeah, does anyone here know a process engineer who says they have too much time in their day? Or that running their plant is easy, right? There are... Every process engineer I've ever spoken to has a list the length of their arm of things they need to do to make their process better that they haven't been able to do because they don't have the time, they don't have the human resources to do it. So the more we can help them and augment them, the better they can make their process.
Okay. Scott, did I catch you? Oh, no, okay. So with Vivek, for you, if a cement producer wants to build their own AI stack, what do they typically underestimate most about establishing that?
I think at the fundamental level, the base of these AI systems is making sure that you're able to collect high quality data from the parts that you're optimizing and setting up a kind of a direction, your KPI on what you're trying to optimize for. So a lot of times, as Noah mentioned, a lot of these experiments don't run to the right outcome is because the initial KPI is not kind of well thought of, and the measurements are all over the place. So some of our customers start by measuring samples across different stages and different devices, but the more we get the fidelity of that particular data, the better these systems are able to develop predictions. So I think from a capability perspective, the biggest bang for buck is having right source of truth systems for data, making sure that there is clear KPI on what they're trying to track, having a close feedback loop on building trust and confidence in these systems, and that's basically a flywheel that over time lets you explore more part of the ecosystem. Again, for cement producers trying to build all their own, they need to start thinking about what are the aspects which is basically in their things that they want to build differentiation on. Is it right for me to build an LLM-based chat versus trying to kind of work with a provider, kind of solve the first fundamental problem? So again, you need to start where is your starting point, figure out that starting point, but build an experimentation mindset. And that comes by investing in really high quality data sets, source of truth, and building a clear understanding of what you're optimizing on.
Okay. Did you want to add to that?
I would say,
Sorry, you next.
if you don't mind. Yeah, I would tell you that the one thing that starting from scratch to build your own is the time. There is a significant amount of time, a significant amount of resources. You know, we actually heard, again, let's reference back to Simpor. He was mentioning if we took, 4 to 5 years of building it up, that's a typical thing from starting from scratch. There are solutions. There are solutions that have been proven out over, from our perspective, we've got 40 plus process optimizations going on across assets around the globe. We're in 22 cement plants running predictive maintenance. These are already proven assets and proven results. It gives the opportunity to take those first steps. It also gives the company an opportunity to look and see what do they like, what maybe they want to improve upon. So again, I think it's a big step to take to do it on your own. And quite frankly, whether you're a large multinational or you're a single plant, getting those resources and investing in that time and that amount is a significant ask.
And I know you wanted to add.
I think we look at to build the AI PC of the future. You need process, you need control, you need software, and you need machine learning. And you need all 4 of those to be sort of really, really world class, and you need them to play well together. And often we see, particularly in the bigger groups of our customers, people we work with, that they have 1 or 2, and maybe they're trying to push for a 3rd. But if you can't do all 4, that will really hurt you. And maybe 2 specific examples of that: the sort of machine learning ops and infrastructure, right? How do you keep a model online, automatically retraining, automatically assessing whether data is out of distribution, needs to trigger something else? Like, that's very unglamorous work that people don't think about, but that will derail control just as much as a controller that didn't work. On the other end, to give a very simple process control example, every process engineer will tell you that LSF should have a massive impact on your free line. But if you don't understand how to use the data, feed it into the right sort of model in the right sort of way, I know people who have spent months trying to build that model with no success because they had all the process control knowledge, but they had none of the machine learning knowledge, or not as much as they needed to make that really successful. So it's got to be all of those things together.
Let me just quickly add, I think what Noah was also pointing at, there's a lot of the 80 to 90% behind the scene machinery that is not visible to customers who are trying to do this all themselves. Yes, there are a lot of things that are kind of opportunities right now to build quickly, but in the real world, you're constantly upgrading, maintaining your data sets. There's a lineage around the data. You are also trying to make sure the models are improving over time. And as you scale, those problems multiply. So the operational challenge also needs to be considered. Right. So yes, there are places where we have seen cement producers trying to think about testing it in a light mode way, but as soon the scale comes in, the complexity of this 80 to 90% behind the scene machinery becomes quite complicated to manage.
Okay, thank you. And Noah, I'll start off with you with this one. How do you see the rise of things like agentic AI and LLMs within the sphere of industrial production? For a cement plant, how do you make the decision about whether to build or buy?
So I think there are maybe a couple things to separate. There's AI LLMs for sort of operator support, training, data analysis. Birkin gave some great examples of that. And then there's AI for process control. And on the first one, I think there are great use cases we're seeing already. We have a bunch of tools that can take scribble down operator notes and turn those into data that our models can learn from and train to be better. On the other side, I think that's what's the most exciting thing that we're talking about. The current set of LLMs are not going to run a plant because they are very good guess the next word machines for a bunch of things that there's lots of data on the internet for. But GPT-1 was in 2018. 2023, 90% of Fortune 500 were using LLMs in their workflows, and now the world has changed. So we're really excited for what is GPT-1 for cement. That's what we're building, we think. These sort of understanding the latent space underlying all cement processes and using that to build a truly autonomous control system.
Excellent. Vivek, did you?
Yeah, I could add to that. I think one big differentiation is the support use case that Noah referred to. A lot of it is, I think, the most accessible way people start using large language models in an environment. I think as soon we give tools, like through the agentic system, this becomes interesting. So again, in our customer base at alcemy, we have a lot of closed-loop implementation. I see this closed-loop implementation as almost like layer 0 of an agentic setup, where agents have a goal, and you are given guardrails, and the agents can then figure out what's the right solution to have. So I'm quite ambitious on what Noah said. The GPT-1 moment of cement is coming very soon, and I think we all are working on each part of that equation. I think aspect is to think about one. I think we sometimes, overestimate in short term and underestimate in long term. So as soon we give a lot of the tools access to these agents, is able to perform set points. Again, we are referring to the last presentation a lot. So in Shimper OAG, they were able to directly give the set points to the systems deployed locally on site, and they can take actions on it based on conditions. I think this is where the future is heading.
Scott, you were nodding. Yeah.
I think as far as where this is going, the LLMs are an opportunity for us to expand even more AI solutions in the industry itself. When I think about logistics, when I think about sales, when I think about all of the other items that are outside of a cement plant per se, that's a big opportunity. That's a big opportunity for us at CemAI and what we're looking at as far as our total solution. But I think, again, on the agentic side, there is enough inherent knowledge of the employees. We're talking about the control room logbooks, OEM manuals. There's enough information there for us to be able to pull together a lot of these things to really take it to the next step. So we're just enhancing the basics of what we have there. Do we get to GP1? I'm excited about it. That's certainly one of the phases that we see there. But it's all building on the fact that a full solution and going digital across the entire industry itself, it really gets to the whole decarbonization aspect of it.
Excellent. Well, we had a question come in here from the audience. So who wants to take a stab at this one? Where do you see the role of first principles in the AI age, for example, thermodynamics for process or product optimization?
I can definitely start. I think it comes back to those 4 pillars. Purely data-driven approaches don't understand thermodynamics. And there are, everyone here is aware there are hugely nonlinear, complex, difficult relationships to understand in the data. So you need to build models and control systems that bring those 2 things together. They come from both what you can see in the data, and they also come from the understanding of physical systems. And even more than that, it can help operators right now. So to give an example, we were looking at blockage detection in one of our customers in South America, and the operators were convinced that it was their magnesium levels that were driving their blockages. And we built a blockage model that did not use magnesium. We did a whole load of data analysis, and we showed them that it wasn't actually that, it was something else. And we were able to both model blockages to prevent in the future and help their understanding of that right now.
Vivek, I see you nodding.
Yeah, I do. I think I may have kind of a general answer to this question. I think what Noah mentioned is absolutely true. A lot of the inherent learning happens if the relationships around the first principles, understanding of physics is very inherent in the data. Whenever that is not inherent in the data, especially the question that you asked about large language models and agentic, there needs to be a feedback loop. So, machines learning through feedback. Again, we will see very soon real-world, world models, robotics in the real environment, where things which are not in just data that is available in the training set, but something that they're interacting with, allows them to experience these first principles head on. So I think there is a role for first principles in the AI age. We are still at the beginning of what it could look like. A lot of these will come from machines trying to feel the physical environment, but also learning through human feedback. And I think that's where I see a potential of expanding into different areas.
Okay, excellent, thank you. And Scott, did you have anything to add to that?
Nothing to add.
Okay, excellent. But for you, Scott, now where do you see the sort of the balance of value when it comes to adopting AI in cement? Is it more a case of preventing downtime or optimizing process performance, or is it a sort of fairly even balance?
For me, it's both. Happily, because those are the solutions that we have out there in front of us. Personally, we like to use the analogy of the self-driving car, and we actually use the analogy of a car in a lot of things, right? We think of the check engine light as the predictive maintenance type of side thing. We think of the self-driving as the process optimization. I think one of the old adages is you can't optimize something if it's not running. Well, if you don't know if it's running, you need to, can we get everything we can get out of it if it is running? It's a good balance to have there. When we think about where that leads to further down the road, and when we think of whether it's decarbonization or process optimization, whatever may be there, the ability to have the availability of the equipment is key. That's the first thing, right? And so if we can improve the availability, reducing the mean time between failure, having that overall equipment efficiency, kind of the basics of it. If you have equipment that's running and you really need to go squeeze that next 10% out of the machine, you need to go get some more energy reduction. If you feel like the plant is already in a situation where it runs fairly well, that's really the opportunity to go and get some process optimization, whether it's around specific energy consumption, whether it's around throughput. Is it on quality control? Each of those in their own way are going to drive specific savings. And so I wouldn't necessarily put one in front of the other, but I would say that if your efficiency of your plan and your availability of your plan is high enough, get with the optimization. You'll have bigger impact possibly on cost control, on CO2 emissions. But again, if your plant's not running efficiently at all, you'll have everything from emission problems to everything else. So there's a balance there, and I think it's very dependent on the customer themselves.
Okay, thank you. Excellent. Well, let's move back to this question here from the audience, and it's sort of touching on that human-in-the-loop situation we talked about earlier. How do how cement plants manage safety concerns if AI is involved more and more in process decisions? Should I pick some of the audience?
No, I'll start away here immediately. A number of ways to look at this, right? We have safety of personnel in the plant that we're concerned about. We're not really taking decisions that will put anything at risk, right? This goes back to the concept of self-driving and the human in the loop. I think it's absolutely critical to know that this is not a set it and forget it, take everyone out, you'll automate your plant, and everything will be fine. A number of plants and a number of customers that we're working for actually don't see a reduction in the amount of people, and so they continue to be out there. They continue to do the work, but we keep that human in the loop in some instances. Another way is, we're thinking about centralizing some of the control room operations as well. Those are some of the other things that cement plants are thinking about, cement companies are thinking about. Adding an extra layer that our colleague at Simple was talking about with the safety side of things. That adds that really takes a lot of some of the risk away as well. So again, it's a combination of things. Clearly, our safety has got to be first when it comes to this. We don't need to put anything or anyone or any piece of equipment in jeopardy. That has to stand as our foundation here. But I think a robust system of planning and being ready for there probably takes care of most of the safety concerns.
I think I could add an aspect.
Just so you know, this is not Terminator 2, Rise of the Machines that we're talking about AI. So go ahead with that.
I agree.
Yeah.
I think I see a change in the skill set of the plant team with these concerns coming in. I think a lot of need to be retrained, also upskilled around what does managing a safety concern looks like in an AI native environment. What does a guardrail look like? What are the thresholds we need to set? I mean, in our area, when we work to optimize cement strength, we definitely provide thresholds on what is acceptable strength or not, and we can provide that upper ceiling and lower ceiling to the lower full floor to that. But a lot of it over time will come from people experiencing and getting more trust that recommendations work, the predictions are working, closed loop is working in our case, and then figuring out what could be the new role for them, and it could be understanding the safety nature of an organization. So I see maybe the first question that you asked about job displacement, I would say an augmentation. Every plant team and plant member is a safety engineer, understands safety guardrails. And as Scott said, it takes step by step. Safety almost could be the layer zero that cannot get wrong. And then everything can work around that. So designing these systems to be in such a way that safety is almost kept it as a heart of our system, which I think a lot of us also do when we develop all these products.
Okay, excellent. And no, did you want to add anything to that? Or?
I think the way I would think about it is, in 10 years' time, operating a cement plant without AI will be like flying a plane without autopilot. I don't think anyone today would suggest that was more safe than flying it fully manually. So like the safety aspect comes from both together. And then maybe to briefly touch on Scott's answer for the last question as well, we look at process optimization first and then maintenance, but it has that effect, like it is all a holistic effect. The less blockages you have, the less you have to send someone into a dangerous environment. And so, a customer of ours in Heidelberg, Mokra in Czechia, we saw throughout our sort of evaluation with them a reduction in sort of 4% in fuel cost and 2% in CO2 from the process optimization. But that also almost doubled their mean time to failure, which means that you are protecting those people more from that environment and therefore increasing safety. Me, I'm going to disagree slightly with Scott. I think in a mostly a friendly way. I don't think it doesn't require a really good process to start optimizing. We've worked with plants who are trying to push their TSR, their thermal substitution rate, from 86 to 90%, and that's a fantastic process. We can, got their TSR up to 89%. But we've also worked with plants who are at 15% and struggling with supply and are really trying to manage that base level. And there's still optimizations gains to be had there, even if you're going from 15 to 18 rather than 86 to 89%.
Okay. And staying with you for a moment now, I'm going to put you forward for this question.
Yeah.
Obviously, this is a question about how cybersecurity ultimately. So how will AI systems be protected against things like hacking and so on when it's connected, when everything is connected via Wi-Fi into the internet? What things should cement producers be taking into account?
Yeah, 100%. Safety is critical in your AI systems, just like it is in your process control systems. Any good AI provider, any software provider will have layers and layers of security and backup. And it also, the control signals and the modeling that goes from the cloud to the plant is different than the things that happen on plant site and control the system. So, just because it's connected to the internet doesn't mean it's necessarily more or less safe, but that is a critical safety concern, just like any other process safety concern.
I think from my side, the question about how the system is protected against hacker attacks when it's connected to internet. So the good news is a lot of the work around cybersecurity over many, many years is going to be super useful here. Those are almost hygiene now.
Right.
So which is good news because you don't have to invent something new here. Having said that, having worked with these technologies like language models, agentic, new surface areas of attacks will happen, as with any new technology. And I think with adoption, with a lot of people using it, we will try to figure out ways to tackle it. But with the question itself, as soon you connect to an internet, I think essentially means opportunity for cement producers and suppliers working with is your hygiene is a starting point. So get those hygiene in, making sure that you're following the best practices, which has been there since forever. And now it's a great time to kind of take that hygiene and put it in play. The most important piece which is missing, maybe that's not what the question asked for, is prioritizing it. A lot of times, cybersecurity initiatives are almost like the priority number 20 of a list of 100 things. And that's where I think when we are enabling these new systems coming in, where it's closed loop autonomous, cybersecurity aspects will kind of rise up on the priority list for a lot of the providers.
Scott, you're nodding along.
All good.
Okay. So we'll move to this other question from the audience as well. So AI will fundamentally transform the way cement plants operate. We're all agreed on that, I think. What new skills will be required to run future plants effectively? Are we looking at new skill sets for staff training and things like that?
I love the question. Cheekily, I'd say I'm not sure yet. And I think that's something that a lot of people are thinking about. The way we look at it is like it's an excitement in what's coming and an opportunity to learn those things. And that will serve you better than any I can do this set of data analysis with this language in this way. So I think that enthusiasm and curiosity and desire to learn is key because these tools are so good at teaching. I think beyond that, an understanding of sort of data and being able to sort of look and understand numbers and then bring the real world into that picture is going to be critical. But that's all based on a bedrock of if you're excited, if you have people who are keen to use these tools and to learn and to get their hands on the latest thing and to work with the new provider, that's going to be the bedrock on which you build a successful future plant.
Okay, excellent. Now, markets can differ pretty dramatically in terms of priorities and digital maturity. How do you build a platform that adapts to a local context while staying scalable? Vivek?
Can you repeat the question one more time?
So yeah, how do you build a platform that adapts to a local context whilst also being scalable?
A platform which is scalable.
Yeah.
I mean, you need to start by testing what works and building a kind of a learning loop around that. And then scaling will obviously increase cost. So you need to figure out in which parts of your stack you want to apply economies of scale. So essentially means which part of your stack is essentially a commodity. So your cost of operating, cost of improving is almost negligible because that essentially solves your scaling problem. So to your question about handling, I think a lot of our, especially when you're building cements with lower clinker, you would start looking at SCMs, and that obviously makes the whole chemistry volatile. So, which will be difficult to then manage it using a manual process, and that's where investing in systems that do intelligent prediction control and making sure that other plants can learn from it would start being almost like a clear, table stakes for plants who are looking at scaling. So, ensuring that you are getting understanding on what is the commodity for you when you start to scale across different plants, building confidence and creating learning loops in your product. If you are basically going into new area, like for example, cement plants producing cements with lower clinker, in our customers, there is essentially not going to be any, I would say, hard problems to solve when you're trying to do manual control. So that's where you need to start looking at, automated prediction and closed loop monitoring. So those are the areas where I see scaling would really be useful.
Okay. No. Oh, Scott.
Yeah, no, I think a couple of thoughts here. So we're fortunate from CemAI to work with some of the best software developers and engineers around. So that's the basis of being able to build a good product. You talk about the differences in what priorities may be, or even different regions, what's going on there, what the challenges may be. We have, we're in Africa with Dangote at a number of the plants. Those are actually quite advanced on their sensors, very unadvanced on their IT protocol and what they have as far as their IT/OT setup there. The good news is again, going back to the software companies and developers that we work with, the work's been done. And again, from our perspective, with having the cement background, with all due respect, a cement plant is a cement plant is a cement plant. If you do waste heat recovery, that's a good thing. We can, we work on waste heat recovery. We work on a lot of other processes. A 5-stage preheat or precalciner versus a 6-stage, or there's not a whole lot of difference there. Vertical roller mills and cement mills. We're not talking about brand new types of processes here. So that being said, we've done the work. We've built it out. We've been in the industry enough that we're not having issues on scaling it up. And we've been able to lay these out and have the number of installations. Once you have that in place, there's no need, with all due respect, there's no need to reinvent the wheel every time, right? This is the concept of, you saw in Bakar's presentation, the concept of digital twins. Not every plant needs to build a digital twin, but if you've seen enough, if you've seen 40 different assets across the world, and you've seen every ball mills and vertical roller mills, and you've seen different types of kilns, that knowledge base and everything else really brings it together a lot more quickly.
Let me quickly add one additional thing to that. I think one we are seeing also in the live environment, when we do start doing large rollouts under an enterprise, under a large group, standardizing how the lab data is accessible to us becomes a very important element. So that's where we have seen some customers having very comprehensive data lake, where all their plants' data is in one place, so that the cost of integration with these plants for each additional plant is not very high. So I think that's another example that when we start scaling, what parts of our ecosystem of capabilities can scale easily, and maybe investing in the right source of truth becomes a great opportunity to kind of reduce the burden of kind of adding on new plant to the system.
And no, I know you've been wanting to chime in.
Well, I get to wholeheartedly agree with everything said so far. There are more that unite cement plants worldwide than divide them. Maybe to give a slightly different skew on the answer from a sort of modeling perspective, one of our fundamental beliefs as a company is there is a shared latent space across the cement process. You are spending a lot of energy to calcinate some limestone and clay and come out with some version of clinker. Right? There is a shared latent space across every plant that does that in every way. And so we're building a system that every plant we work with makes that latent space better, makes that control system better. And that fundamentally, another of our core beliefs is that configuration beats customization. So taking that shared understanding of what this chemical physical process is and configuring it to, do you have an inline calciner or not? Is much more effective than starting from scratch to build a new model every time you do it.
Okay, and sticking with you, Noah, for just a moment, I think we're going to wrap things up as we are drawing to the end of the day. Looking 5 years out, or perhaps 10 years out, what do you think will be the most transformative AI capability in cement plants that we haven't potentially really seen yet?
I want to borrow Scott's idea.
I'm letting you go.
We'll go down the line if you like.
I mean, you've been talking about self-driving cars, right? So I think it will be great to use that analogy here. Plants learning from other plants. I think that's, for me, is not a kind of a rocket science or a breakthrough. It's already happening in different industries, and we can learn from that. So essentially, plants improving not in isolation, but across plants. And that's where I think I see a lot of value in, because then you're not restricted with how much of knowledge exists within a particular plant, but rather you're learning from other plants that are operating maybe in a particular group or even outside. Mm-hmm. So I would say that if I had to make one bet and crystal gaze, I would say that perhaps feels to me that we are probably going to see.
I will say this. I think it's I think it's probably a good vision to have there. Look, we still have to get past, and this is not to throw a cold towel on it, but I think about, how can those smaller 1 or 2 plants learn from others? There's still a lot. This data, production data, quality data, historical data from plants is very, very, very valuable. Extremely valuable. It's one of the closest held information that these plants have, right? You know how much you can figure out how much they sell, you can figure out how much they produce. That data that they have, though, is really the most valuable piece of information that's closely held. I think Vivek is 100% correct. If we can get to the point that as a whole we're wanting to share more information, it will elevate the entire industry and take that next step. I think from a little bit different perspective, it is really starting to put your arms around the entire cement process, from extracting materials all the way through end of sale of and placement of concrete in 3D printing or wherever it may be. There is an opportunity to link all of those things together. If you think that the 3D printing house doesn't, or that the quarry does not impact how the 3D printing house is actually done, you're kidding yourself. It is. It all combines. It all flows together. So somehow getting all of those pieces together into a livable AI machine learning type of digital package, I think is a big ask, but I think we're well on our way there.
Okay. Noah, last word.
Yeah. To finish us off rather than start off, I think I'll answer this in 2 ways. The next big thing I think is going to happen in the next 2 years is we're going to go from an operator, a process engineer, someone running the kiln, sees something that goes wrong, tries to dig into some rule blocks and logic, fiddles with it, doesn't know how to fix it, and calls a commissioning engineer. We'll go from that to they see something goes wrong, they tell the machine it's gone wrong and why it's gone wrong, and the control system learns from that and doesn't do it again. I think that is very soon going to be the normal thing that everyone will do. And then, that's the next 2 years, maybe the 5 to 10 years is, again, this same belief of we will have a foundational cement model, and that is what's going to drive control at a really kind of deep level.
And GPT-5 offers.
Well, we'll see.
Okay, well, excellent. Thank you so much, guys, for your contributions. Round of applause. Thank you.